So good morning class. Today I'll be discussing and introducing vapor compression refrigeration system. The current session includes introduction to vapor absorption refrigeration system, how it is different from vapor compression refrigeration system, and what are the advantages of vapor refrigeration system. I will also be introducing the most common type of refrigeration, vapor absorption refrigeration system that is used, which is the ammonia water system. Now, we'll start with an introduction to vapor absorption refrigeration system. Now, in our previous classes, we have discussed vapor compression refrigeration system, and it has its share of advantages as well as the disadvantages. Now, one of the major drawbacks associated with vapor compression refrigeration system is that the compressor needs to handle large volumes of refrigeration paper. So, since it has to handle large volumes of refrigerant paper, it requires more mechanical energy, and in turn, it requires more electrical input. So the work that we give to the system is increased, and thereby COP of the system is actually decreased. Now, if we find an alternative method to the compression process, or if we are able to reduce this volume before compression, then there is considerable reduction in the weight of the system, as well as power requirement for the operation is also reduced. Now, this is where the vapor absorption system comes into play. Now, although vapor compression refrigeration system have a lot of components common to the vapor compression refrigeration system, that is, vapor absorption and compression have certain components in common, but the main difference lies in the method by which vapor absorption system compresses the refrigerant. That is, in a vapor absorption system, there is no compressor, and it is replaced by, or instead of a compressor, we go for an absorber, a generator, and a pump. Now, such a system as an alternative to vapor compression systems. Now, this is actually serving as an alternative. It has several advantages over vapor compression system. The first of its type was discovered by a French scientist, Ferdinand Cain, who developed the first system in the 1860s. It has undergone a lot of changes now. Currently, the vapor absorption units that are being developed they have a capacity of around 1,500 tons. Now, we are entering into the main topic, that is the vapor absorption refrigeration system. It consists of, or the cycle consists of, mainly two fluids. One known as the absorbate or the refrigerant, and the second one is called the absorbent. Now, the commonly used fluids are the ammonia that acts as the, let's see here, yes, ammonia that acts as the refrigerant, and water as the absorbent. Both of them are combined and as well as they separated during the cycle of operations. So there are two components, mainly the absorbate or the refrigerant and the absorbent. Now here ammonia, we'll be discussing ammonia water system, where ammonia acts as the refrigerant and water acts as the absorbent. Now, this is the most common type of vapor absorption refrigeration system that is being currently used, which is the ammonia water system. Here, as you can see, ammonia is circulated throughout the system. Here in the evaporator, the condenser, again. So as you see in the entire system, ammonia is completing the cycle. So it acts as the refrigerant, whereas you can see here water, it acts as the absorbent. Now, water has the capacity to absorb ammonia in large compounds. Hence, ammonia water combination is used. Here, as you can see, the figure is almost similar to the vapor compression system. That is, you have the condenser, the expansion valve, and the evaporator. But the main difference lies, as I have discussed before, is the replacement of compressor by an absorption unit, a pump, a generator, a rectifier, and a regenerator. Now, the working is quite simple. Actually, what happens is, after absorbing the heat by the ammonia, the liquid ammonia here absorbs the heat from the refrigerated space. It turns to vapor ammonia at a low pressure and temperature. It is then given to an absorber, from where it is mixed with water. So the combination of ammonia vapors and water is then pumped using a pump. It is given to a regenerator, and then it reaches the generator. Once it reaches the regenerator, it is supplied with an energy. Now the advantage of vapor absorption system is that we can use waste heat that is rejected by other system, or non-conventional, or that is we can use energy that is easily available. For example, solar energy. In this case, it uses solar energy. So this solar energy is given to the generator, wherein this mixture of ammonia and water is heated. So what happens is, when the mixture is heated, ammonia vapors separates, and these ammonia vapors are then given to a rectifier. If at all any water vapor is present along with the vapor ammonia, the rectifier removes this water, condenses the vapor, and then it is sent back to the generator, and the vapor at a high pressure and temperature enters into the condenser where it rejects heat to the outside or the surroundings, and a phase change process takes place wherein ammonia vapor at high pressure and temperature is converted, as we have discussed earlier in vapor compression system, gets converted into liquid ammonia at a high pressure and temperature. Then there is given to the expansion valve where it is expanded to a lower pressure and temperature. The expansion will be isenthalpic in nature. So at the low pressure, low temperature, ammonia liquid, actually here phase change takes place, condensed, that is ammonia vapor gets converted into ammonia liquid. Here there is a pressure change, the pressure and temperature decreases. So the low pressure, low temperature liquid ammonia that enters into the evaporator, wherein it absorbs heat from the refrigerator space. So the refrigerator space is maintained at a lower temperature. So here again another phase change occurs, that is the liquid ammonia entering the evaporator is converted into vapor ammonia by absorbing heat from the refrigerator space. So this low pressure ammonia then enters into the absorber where it is again mixed with water. Now see, and a question comes, what happens to the water? Actually NH3 vapor gets separated. Here what happens is the water also gets heated, it vaporizes, but what happens, certain quantity of water is condensed here. That water is then passed through a regenerator, right? So again what happens is it has a certain energy. That heat energy is then supplied to the fresh NH3 water that is going into the generator. So as its heat energy or its heat content reduces, it is given to the expansion valve where the pressure reduces and the water is then given into the absorber where it again absorbs NH3 vapor and the cycle continues. Right, so actually water circulates or water completes the cycle between the absorber, pump, regenerator, generator, and then back to the absorber, whereas the refrigerant NH3 is circulated throughout the system and undergoes phase changes. Now we go on to the COP of the system. Actually the COP is the ratio of cooling effect to work input. Here cooling effect is actually the heat that is taken from the cold refrigerated space, and work done is here there are two categories, that is first one is the heat generated or the heat absorbed, solar cell that absorbs the heat which gives heat into the system, and the pump work. But what we do here is that the work input to the pump is usually very small, so we can neglect it. It becomes economically attractive when there is a source of inexpensive heat energy at a certain high temperature. That is, this is the main advantage, that is we can use inexpensive heat energies or waste heat that is rejected by other system in this vapor absorption system. Now the advantages. First one, it has no moving parts, the operation is very quiet, and it has very little wear and tear, so that the maintenance cost of the system is low. Now the pump motor is quite small when compared with the compressor motor, so the pump work can be neglected. Then the vapor absorption system uses thermal energy. There are certain situations where electric power is hard to obtain. In those situations we can go for thermal energy or waste heat from the other systems. This is one of the major advantages. And these absorption units can be built in capacities well above 1000 tons, and their space requirements are very less. So as you can see, there are considerable advantages of vapor absorption system over compression system. That is, no moving parts, the pump motor quite small when compared with the compressor motor, thermal energy can be used when electric power is hard to obtain, or waste heat can be used. They have larger capacities when compared to vapor compression refrigeration system, and they require less space. Now in the next class we will be discussing in more detail about vapor absorption systems, including the Electrolux refrigeration systems and the lithium bromide systems, which are variants of vapor absorption systems. So thank you and have a nice day.